Halo,文硕，你后来有转系吗？哎，
每天都是你拜一到拜四都
拜四。
班长没有来，班长没有来。
再查。
有些人
金宝呢？金宝
我还没有借，最不是有的三
迷路啊，迷路啊，traffic jam 啊。Where's your class monitor?
哎呦，他过来挖呀，这个中去了，这个中间。他可能忘记点，他不知道这个上去了。啊，这个我都可以填。经常我看看还有，不要填错好这个直接填。
Testing, testing. All right, I think we should start. So sorry that the aircon is not working. Yes, so please bear with it. All right, good morning to everyone. So we end at the same place and started at the same place. G09. Okay, A4G09. Okay, very happy to see all of you again. How's your holidays? How's your holidays? Free for Wednesday, good. Take a good break. Okay. Okay, most of you, you know me, okay, and I know you, and we have some new friends here as well. Maybe I should learn your name later. So my name is Seng, okay, or my last name is me Seng. So you can call me Seng, okay. So people call me sir, doctor, but don't call me professor, okay. I'm not professor yet, but you can call me Kiseng also, okay? Because we're like friends, so you treat us, I treat you like friend, you treat me like friend, so we respect each other, okay? Because people make mistakes, so don't expect me to be correct all the time, okay? So you should question, okay? Question me, and then I'll give you the answer. And I question you, you give me the answer. So this is how my lecture works. So um, you can throw any question anytime. Okay. Make sure you have some doubt. Okay. Doubt in your mind. You should clear it soon or later. Okay. And I realized from last semester, right, most of you didn't follow my instruction, then result in a poor performance. So, so maybe because of your English or my English. Okay. So sometimes maybe I need to take advantage of this university. That is Chinese is one of the medium to communicate. So if I want to speak Chinese or Mandarin in class, I will translate to English. Okay, so I will state some key instruction in English, Chinese, okay, to help some students here. So yeah, is it understandable? 可以吗？理解吗？ OK，重要的东西我用华语说，OK，and then I speak in English again. Okay, so I do it bilingual. Otherwise, some just miss it. Okay, 可以吗？可以 get 到吗？ Yeah. Okay. Yeah. But content is still in English because I'm not familiar with Chinese term. Okay. Instruction, some key important instruction I'll give in Chinese. Okay. Um. Okay, my name. Okay. So in this semester, I won't ask you why you do maths again. Okay, you should pretty sure why you are doing maths. Okay, either you want to go apply, either you want to go pure. Okay, but anyway, so this semester you start with two major core, analysis and algebra. Okay, both of these are pure maths. Okay. it doesn't matter you want to go apply later, but you need to learn the skill from these pure maths, and then you should apply it in other various cases. Okay, so now we are getting into the real business now. Okay, so these are pure maths. Yeah, so maybe I want to show you some important stuff from my department meeting. I think, should we close the light? Yeah. Okay. So maybe let you know what's going on, so that you know what's this school trying to achieve, and then we all are working towards it. And so there's a university vision and mission here. So SMUN aspires to become a university with a distinct global outlook, featuring first-class teaching and research and embracing cultural diversity. So that's why you will see our school is so international now, I think. Did you see a lot of different races, people? And the mission is to nurture young talents with dignity and wisdom, okay? Turning them into fine citizens of the region, okay? Who will make contribution to the prosperity of the people and society progress of Malaysia, China, and Southeast Asia. Understand? Okay. Let's see how we work towards this. And the university motto is pursue excellence and strive for perfection. Does anyone know the Chinese version of this? Was it? Was it Li-Kai? You don't know how to say? What's the Chinese version of this? Don't know. No. Anyone know? Okay. One is 自强不息, the other one? 止于至善, okay? 自强不息, 止于至善, okay? So pursue excellence, okay? Pursue excellence, strive for perfection. This is there's a good illustration last semester, okay? One of you got 29 in the midterm, but you got 92 in the final, okay? So it's possible, So please work hard. Everything is possible, okay? 29 become 92, okay? Within 1.5 months, right? Okay? It is possible, okay? So don't give up on yourself, okay? And I won't give up on you, okay? You can seek help from me. Okay, we come to this department vision. So what's this MAT department doing? Become a leading department for mathematics in Malaysia, offering first-class education of mathematics so that our students can appreciate the beauty and usefulness of mathematics. Okay, so in mathematics, remember last time I told you 2 key values as are important is truth and beauty. Okay, truth and beauty. Okay, so this is also used by the IAS Institute for Advanced Study. Okay, the top institute doing research in mathematics. Okay, truth and beauty. And so why we do maths? Because of truth and beauty. You know the truth, and the truth will make you free. The truth will make you free. Okay, quickly go through this. So department mission is provide first-class maths education and training to students that want to pursue a career related to mathematics. Okay, so hopefully whatever you learn in the maths, you should apply in your various fields. Okay, in your real life, in your working stuff. Okay, working life. And so we serve all the program in XMUM, as well as all the GE courses, service courses. Okay, and then another thing is this semester you guys are going to do ME, right? Okay, so there's one point here: encourage our students to think critically. Okay, so I think from the last semester I'm starting to tell you this. So this semester we should do more on this. Okay, think critically. Okay, more importantly, now you are doing proof. Okay, statement proof, statement proof. So statement is relatively short. Okay, so you need to gain information from some short statement to prove some great result. So this is what you need to learn. Okay, and okay, so this is for ME. We have an alternative assessment. So let's go to our assessment. Okay, so does everyone here already in the Moodle? Who is not in Moodle yet? Can you let me know? Anyone of you is not in the Moodle yet? Okay, so if you have the Moodle, okay, you going to the Moodle, the first thing you see is the, okay, check that you're going to the right course. Okay, you check whether you go to the right course. So this is MAT211 abstract algebra. Okay, so what we were doing here is group theory and ring theory a little bit. So this abstract, I get it from one of the textbook, okay, from the preface of one textbook, which is this one, Michael Artin. So the textbook we are focusing on is this two, okay, by Michael Artin and Fraley. So all apart from these textbooks, I also put some suggested readings, okay, if you want to read. Okay, if you think that I don't understand this textbook enough, okay, 我不明白这个课本, okay, please go and read these other textbook. Okay, if you don't understand, go and read the other textbook. So sometimes when you go do referring, okay, referring to different sources, then referring to different sources, then um, you will learn more. And I also put some advanced readings here. So advanced, why I separate them into advanced readings is because these are more suitable for graduate class. Okay, it's like for PhD, master, okay, but they're also good to learn if you want. Okay, and then they are more comprehensive. Okay, more comprehensive. Okay, they are more comprehensive. And while I searching for reference, I found some interesting history readings. Again, they compile a history here, so you can have a look, okay, at your free time if you want to know better, okay, how these group theory, ring theory develop. So I put 3 forums here, again, as usual. So once is announcement, so I will make any announcements here, like changing time, exam time, assignment time, okay. And student forum is for you to start any question, ask to your friend, and then your friend can answer it. Okay, but I think no one used it last semester. So I hope that you can be more active. Okay. And then the other one is I put here key sense question time. Okay. So in Parliament, there's a Prime Minister question time. Okay, so you can question me here. Okay. Either I will answer online or I will bring it to the lecture. And then I answer it. And so you can do your ask me question here. So I put the textbook and then the lecture notes, past year lecture notes under the resources. I might put previous year tutorial or homework up also. Okay, so that you have more exercise to do and then you can try and study from there. And then I will come out with a completely new tutorial set and then homework. Okay? So yeah, I'm still thinking about it, but I might do it. Post out the past year. Okay, so week 1 here, that's very important document here. This is really important, 非常重要的一个文件。Okay, course information. Okay, everything your question related to the course, you should consult this document. Okay, any changes I will make inside this document. Okay, please consult this document first, then you consult me. Okay. 如果你有什么问题的话，对这个 course 有什么问题，直接去这个文件里面找。OK， 如果有问题才来问我。OK， All right. So this course information here consists of information, the learning outcome from the course. Okay. So our academic section is 202309. Okay, September. So we are expected to end at December. Okay, 3 months. After then we finish. January exam, right? Yeah, January exam. So the course learning period is just 3 months. And our credit value is 4. That means our face-to-face hour is 4 hours. So we break into 2 days, which is Monday and Wednesday. Again, Monday is 9 to 11 at A4G09. Wednesday is 8 to 10, A5105. Okay, it's the second floor. You can email me if you have any question. You just email me. Okay. So it's my first name dot my last name at smu.edu. And my A4448. Okay, so why I tell you my office? So I have an office hour here, right? So office hour is Wednesday 10 to 12, Thursday 3 to 5. Does this clashes with your timetable or not? Can you guys check now? Yeah, can you guys check? Yeah, are you not saying? Maybe just a general time. Yeah, general time works. So maybe you can just speak out if you have a clash, and then we will see how many of you clashes, and then we will decide which one is the best. Yeah. Thursday. Okay, Wednesday is okay. Thursday you have class from 4 to 6. Okay. So Wednesday is okay for you. Okay. Okay. So you have to speak up now. I need to adjust the time. Yeah. You don't say anything? Is it better than better? Yeah. Okay. So any free times you think you want to do, I will consider because I need to check with the other class as well. And any free slot you guys want me to put on? Friday? What time? Okay, any time during the afternoon, is it? Okay. That's all. Okay, please speak out. Okay. So I care about your so I want to so in lecture I want to communicate with you individually. Okay, so when I speak to everyone of you. So if you have problem, you just speak out. Okay. That's all. That's all the request. So don't put at Thursday, but put at Friday. Okay. And so I will put as on appointment here. Okay, because usually the student won't come at my office hour. Okay, so I just sit there alone. So if you're gonna come, you just send me a message and then I'll be there. Just shoot me a message or email. You are going to come. Okay, and then we can arrange it. So our class structure here is a lectorial style. Okay, because I don't have a tutor with me, so I have to do lecture and tutorial at the same time. So I will do it in a mixed style. Okay, so like last time I will teach a bit, then you do a bit, teach a bit, do a bit. Okay, instead of give you 1 hour and then you sit there and do. Then maybe that's boring. So in each hour we have a 40 minutes lecture. So this is a Q&A interaction. So not just I'm lecturing, so you can give me feedback also. And 10 minutes tutorial. So I put in the middle intermittently, and then 10 minutes break. Okay, 10 minutes break every hour. All right. Is it clear with this class structure? Yeah. Yeah. So learning outcome. So you need to comprehend the theories, concept, and method in algebra. So meaning you need to know how to do. You need to know why. And know why, know how. Okay. Both you need to know. Compute explicitly algebraic quantities or relation with detailed steps. Okay. You need to do with steps. Illustrate the applications of the theories and methods in abstract algebra with proper reasonings and justification. Okay, so this one is proof, regarding proof. Okay, so you need to use proper reasonings and justification. For textbook, we already mentioned it. Okay, and then suggested readings. So based on previous design, we have 5 topics. So groups, subgroups, permutations, posets, and direct products. Homomorphism, factor groups, rings and fields, ideals, and factorials. Again, so you might see these words as a very strange, okay? Because these are the first time you see these words. But I can assure you that you have seen all these examples already. And you have seen these examples. Just that we try to abstract the properties. Actually, there are more things that satisfy the same properties, like groups, rings, fields. Okay? But ideals and factor rings are new. Factor groups are new. But groups, rings, field, you definitely see these examples already. Okay? We will get into it later. And this course assessment only has assignments, tests, and final exam. Okay, so you don't have project. Okay, to do project. We have 5 take-home assignments. Okay, 5 take-home assignments. So I make it due on, when is it due? Thursday. On which week? Week 3, week 6, week 9, and week 12. Okay. 5. So I'll give you at least about 2 weeks. Okay, 2 weeks time to finish each assignment. Okay, it's like last time. So about 2 weeks, 2 weeks time to finish an assignment. Okay, so so I think I should post out the assignment later this week. Okay, for the first one, and then you will have 2 weeks, about 2 weeks time to finish each assignment. So the test I'm planning to put is on 7 week. Okay, so please be prepared. Okay, week 7. And then final exam. Yeah, then we are done with the course. Okay. Yeah. So any question regarding the course information, how this course is designed? Any question? What? Don't talk something other than the course class. Okay. Any question? Okay, if no question, maybe we take a 5-minute breaks, okay, and then we start the lecture. Oh, wait, before there's one more thing. I think that's very important things. So there's a double pass-through in every maths course, okay? Do you know that? There's a double pass-through for every maths course. It's the assessment, coursework, you need to get 40%. Okay? And then overall, you need to get 55 and above. Okay? So you need to pass your coursework in order to pass your course. Okay? Yeah. So this means what? This means assignments is really, really important. Okay, so assignment will be a key factor for your grades. Okay, because I already give you so many time to do. Okay, so you should do it. And you have the resources. Yeah, okay. Speaking about assignment, so you can search online, you can ask your friend, okay, everything, but you cannot copy straight the answer. Okay, you need to put into your own words. Okay, and then you need to cite, okay, where the idea from. Okay. Maybe your friend told you, okay, you said, maybe who is your friend? Maybe Ying. Okay, Ying, I collaborated with Ying, okay, for this solution. Okay. Or I search on this blog post, okay, someone posted on. Yeah. Otherwise, I will count you as a plagiarism. And okay, I need to tell you something. So it's the GPT stuff. Okay, maybe you can go and ask GPT. So one thing I want to warn you is GPT just pick one possible answer to give you. Okay, so you need to analyze yourself whether that answer is correct or not. Sometimes it's also a good exercise to see whether GPT is correct. Because GPT is a language model. Okay, it's not the absolutely correct or wrong stuff. Okay, it's just a language. If language makes sense, then the answer makes sense. Okay, so be aware. So you can use GPT to learn stuff, but you need to differentiate what's correct and what is wrong. Okay, let's take a 10-minute break. Okay, and then we will come back for the real content. In the meantime, maybe I will just take attendance. If you want to go to toilet, it's fine. Okay, I will take it again later. We have a Venus here. Is Le Tian here? Okay. Oh, you are Le Tian. Okay, nice to meet you. Wei Zhe. Yeah, Wei Zhe. Sang not here. Si Yu here. Jing Seng. Okay, good. Nice to meet you. Xingling. Xingling. Xingling, first day already start sleeping. Xingling. Okay, Jingbo. Qi Feng. Wai Ying. Pishon. Okay. Ying Qi. Yeah, He Yi. Good. 雪岩雪岩，yeah，家业，okay，家业 very early today，离开，okay，袁家，okay，文硕，yeah，一定，okay，玉维，玉维，玉维高来了，okay，燕博，彭业，okay good，welcome back，林晶，林晶，okay good，真诚，yeah，硕宁，硕宁高来了，okay。Oh yeah, sorry. 鼓励，OK，yeah，子倩，OK，泽轩，OK，莹莹，OK，Grace，yeah，沙耶，嘉文，嘉文，OK，明秀，Michelle，Brian，Ellie，永志，雪妍。How about Stephen? Is that Stephen? Okay. So, where are you from? Like which class? 02. 2202. Okay. So it is like 1 year before them. 1 year senior than them. Okay. So who was your lecturer last time? Have you taken this course? Oh, you haven't taken. Why you take like? Oh, because you joined the short semester. Is it? Retake. Right. Before what? What did you do before? I did take some course. Oh, I see. Oh, why is that? Why is that happening? I thought this is a major course. Yeah. What do you mean retake? You say you can take this before. If it's another course, so you retake it. Oh, the other course you retake. Yes, and then I see. Okay. So which course will cause this delay? Only Algebra 1. See. Okay, good. And how about I think there's one more guy I haven't called your name. Who is this behind you? Yeah. You haven't decided. You just audit first. Okay. Okay, sure. Yeah, so I think we have all of you except Sang. Okay, your son is on the flight. Which one you mean？诶，我找一下，吴董杰是吧？诶，有啊，没有叫到。诶，我还没有叫完，是不是？对，还没有叫完，我叫哪里了？好，testing。Okay, sorry, I haven't finished my list yet. 陈烨 okay. Yeah, oh, 林晶 I already called. Yeah, 董洁 yeah. 宜州 okay. 丁瑜 okay. 丁瑜 yeah. 刘晴 yeah. 曾诚 eh, why is it I miss out? Oh, I miss out the middle name. Wait, let me see. Did I call everyone here? Yeah, I lost my count here. Everyone got called? Not yet. I already called your name because it was in the toilet just now. Yeah. I haven't called you. Let me see. 雪梅. I called already. Have I called you? Yeah, okay. Yeah, okay, good. Yeah, I think we just left with Sangre. Okay, we got new friends and old friends here. So hopefully you guys will enjoy this semester. Okay, because I said that our lecture is interactive, right? So actually, your lecture with me is kind of like customized. Okay, what do I mean by customized? So first, this lecture notes are based on my interest. Okay, I'm interested on these stuff, so that's why I'm going to teach you. Okay, or certain subject or topics I'm interested, so I put it into this course. Okay. So first is based on my interest. Second is based on your interest. Okay. For example, in the class, you listen to what I say. Okay. Maybe there's some definition or some theorems, and then you want to ask people why is this true or why it works. Okay. Then I will go into explain it for you. Okay. So don't be worried that if you ask question, you will distract me. Okay. I will control the flow. So either I want to answer you on in the class or I answer you after class. Or I see that it is important or it is not important. If it is important, then I will put it to the lecture notes. If it's not important, then I just explain it to you. Okay, if it's just trivial stuff, then I explain it to you. If it's non-trivial stuff, then I put into the lecture notes. Okay, so most probably, so this is based on the chemistry between you and me. So this lecture notes were grown out of the chemistry of you and me. So I don't fix any notes. But I have a trunk. Okay, I have a main trunk that I want to finish. And then you need to add the leaves and you flowers or the fruits. Does it make sense? Okay. 可以明白吗？
Bye.
Okay. So you should keep interacting with me. And then I will make you benefit, you make me benefit. Okay, so we benefit each other. Okay, in this class, so we don't waste time. Okay, time is very precious, right? Yeah, so we don't waste time. So first day of the class, I want to give you this big picture here. Okay, so you come into a pure maths course already. So this is a big picture of our mathematics. So there are few areas, few main areas, okay, in mathematics. For example, let me draw. I mean, so you have topology on the left, okay, and then you have analysis. So what's analysis? Is the calculus stuff, okay, advanced calculus stuff, which you will be. When's your first analysis class? Tomorrow. Okay, tomorrow, yeah. Okay, so tomorrow. So be aware, analysis is very hard in my opinion. So throughout my maths degree, right, the easiest maths course I think is this course, okay, group theory. Okay, hopefully you feel the same. I mean, at least for me, it's the easiest one. Yeah, others is very hard, like differential geometry. Okay, you can see differential geometry. Yeah, analysis is always hard. Okay, I think you will see sequences, not just sequences of number. You need to see sequences of function. Okay. How does a sequence of function works? And then I think you should see logic already in your discrete math course. Discrete math is pretty important in proof. Okay, it's very important in our course because it is a language we use. Okay, the set notation you need to familiar with. Okay, need to be very familiar with set theory. And then how to prove. Okay, how to prove. Okay, later I will speak again. And then there's the algebra. Again, inside algebra you have a number theory, fields, rings, groups. Okay, these are the things you will see. And then algebraic topology, if you go further in maths, okay? If you want to do finance, if you don't do finance, you do pure maths, then you can choose this. Or you don't do computer science, you do pure maths, you can do this. Okay, there are factors. Okay, so there's a moon here. Okay, this is the moon we are looking for. Okay, so all of these hopefully will be covered by this moon here. This is the moon of category theory. Yeah. So if you hopefully go further, we will have this course in future. Okay, category theory. Yeah. So it's what I'm currently using. Okay, category theory. So category theory is another more abstract notion to capture all these subjects. Okay? Hopefully category will become the foundation of the maths. Okay, replacing the set theory. Okay. Yeah. All right. So what is abstract algebra? Okay. So what is abstract algebra? So typically when people heard about abstract, they are very scared. Yeah. Why are you scared? Why are you scared when you hear abstract? Why? Very 抽象. Why you scared about 抽象? Huh? Why you scared about 抽象? Okay, so why abstract? Okay, abstract. Actually, nothing is abstract. Okay, why do I say so? Okay, why do I say so? So listen to my argument. Okay? So why? How do we come up with abstract? Okay, so we look at some examples. Okay, they are real life examples, and then we abstract the properties of. Okay, so we look at few examples, and then we abstract the properties of, and then we just study the abstract algebra. Okay. So what do you mean by one? What do you mean by two? What do you mean by three? What is 1, 2, 3? Tell me what is 1, 2, 3? Huh? Yeah. What's that thing? What's the thing? Is it a table? Is it a bottle? Is it a room? What is 1, 2, 3? You see, since young, you are instilled with this abstract notion. Okay. Normally, maybe the old person will teach you, 1 apple, 2 apple, 3 apple. Okay, this is 1, this is 2, this is 3. When you see 1 apple, this is 1. When you see 2 apple, this is 2. Is it? Is this how you learn 1, 2, 3 or not? Is that right? In the kindergarten school, right? They put 1 sheep, 2 sheep, 3 sheep, right number beside the sheep. Right? Correct? So these are abstract notion. 1, 2, 3 are already abstract. You are already touching the abstract stuff. Okay, so we are going more abstract now. Okay, abstract algebra. So I would say that abstract algebra is ubiquitous, so it's quite common. Okay, in the maths. Okay, you are already doing it. You are already doing calculation with them. Okay. And then algebra, you should know, right? Algebra is like x plus y, y plus z, x times y. Okay, this means we need to do some composition. Okay, so we do composition abstractly. We don't care where it is from. Okay, so this is abstract algebra. So what is abstract algebra? We want to do composition abstractly. Okay, we don't care whether it is an apple or a table or a room. Okay. Why we don't care? Because as long as you satisfy certain property, you can just apply the theory. Okay, you can just apply the theory as long as you satisfy a certain axiom, properties, relation, and so on. Okay, so that's why it is universal to this relation. Okay, so let me repeat again. Repeat again. Okay, good. So repeat again our structure here. So our class structure will be in a lectorial style. Okay. So first, ideally before we go into some theory, we will give some motivation. Okay, or ask some question. Okay, ask some question that works towards the theory, or we observe some things. Okay, observe some property, and then we try to learn that properties. Okay, then to prove everything, it's very crucial that you need to know the definition of every word in your statement. Okay, so definition is very important. Whether you make a good definition or bad definition. Okay, if you make a good definition, you can do a lot of stuff. If you make a bad definitions, you can't go far. Okay, so definitions or axioms. Okay, axioms, definitions. Third, so of course, okay, definitions is already like abstract stuff, right? So we need to have examples in our mind. Okay, we need to have clear examples in our mind. So whenever you see, I don't understand this definition. Okay, that means you don't have some clear object inside your mind yet. Okay, so you need to go and find the examples that demonstrate the definition. Okay, so once you see a definition, I don't understand this definition, please give me the example. Okay, you can ask me. Okay, I give you the right to ask me, and then I'll provide you. Okay, if I can't provide you on the spot, then I'll provide you later. Example is important. Non-example is also important. Okay, non-example. Something is a group, something is not a group. Okay. Non-example is also important. So then from these definition axioms, then we will develop some useful statements like theorems, propositions, lemma. Does anyone curious why there are three different words here? They are all correct statements being proved. No one question why we put like this? Anyone question?
Is there a state of verification?
One is depend on the how we use it. The other one is depend how important is it. Okay. Theorems is like a very big theorem, very useful or very important one. Proposition is like some maybe usual properties. You're not sure whether it's true or not, then you prove it, or you need to show that something trivial is true. Trivial, I mean less difficult. And then lemmas. Okay, lemmas is very important. Lemmas is the statement you need to prove, okay, before you prove the other theorems and proposition. Meaning, like in the step you want to prove proposition, you think that hey, this line is non-trivial, very important. So we call it a lemma. Okay. So it's some statement you use to prove theorems and proposition. So you don't think that lemmas is very like less useful, but it's kind of useful. I think there's a name. I think there's one name. I'm not sure it's Gauss lemma or Hooke's lemma. Yeah, it's a very famous lemma also. Yeah. Okay. Yeah. So theorems, propositions, lemmas. Okay. So after giving that, I should present you the proof. Okay. Or sometimes we just sketch the proof. Okay. So the proof is very important, as this is the key item you need to learn and demonstrate. So how to prove? How many ways to prove a statement? You need to recall what did you learn in your where is it? Discrete math, yes. So what's the how many ways you learn to prove stuff? Okay, can you state some of them? Okay, so what do you mean by direct proof? You just look at the statement, if, then, for example, then you just use the what is it? Use the condition you given and then prove the condition that you want. Okay, direct proof. How about the other ones? Okay, contrapositive. What is contrapositive? Not quite. Okay, so contrapositive is if you want to prove P implies Q, okay, what you can do is you prove not Q implies not P. Okay, so instead of going from P to Q directly, you start with a not result, not your result first. Okay, not Q, and then imply not P. And then if you can prove not P, then you will get P implies Q. Is that okay? Please remember, at least for this class first. Okay, you can go back and think why is it true, why is it true, why is it true? Why is it true? How to show that this is true? How to prove the statement here? Logically equivalence. What's the definition? Yeah, right. So how to prove a statement? Need to go back to the definition. What is the logically equivalence definition? Same truth table. So you need to plot the two truth table and then see that they are true. Okay, that's all. You need to use word. Okay. Other than contrapositive, what do you have? Contradiction. Okay, contradiction is very useful technique. Okay, you must know contradiction. Okay, contradiction is very useful technique. So what's the contradiction? Yeah, so what's the wrong statement you need to assume first? Hmm? What's the wrong statement you need to assume first? Let's say I give you a P implies Q. Assume not Q also. Okay, assume not Q also. You assume not Q, but you also assume P. Okay, but you reach not P. Okay, not P and P cannot exist together. Okay, so this is a contradiction. Did you see some similarity between contrapositive and contrapositive and contradiction? Did you see any similarity here? Yes, you assume that the conclusion is false. Okay, both of them assume the conclusion is false. Okay. But in contradiction, you have an extra condition you have. What is that? But the assumption, okay, is true. So you have two pieces of information to start with. But contrapositive, you only have one piece of information to start with. Okay. So depend on which way, depend on the statement, okay, and then you will see which one is better to use. Okay. Is it okay? Okay. Because now you are still new to proof, right? So you can try this possibility and then to see what happened to your statement, what you need to do to achieve this proof. Okay? Yeah. Once you practice enough, then straight away you can see that, oh, this statement is easy to prove using control positive. This statement is easy to prove using direct proof. This statement is easy to prove using contradiction. Okay? Yeah. So we will like use contradiction or contrapositive when the assumption is not very useful. Okay. But we can start with the result. Okay. Negative of the result. All right. And then some other proof technique like induction, you also need to recall, okay, proof by induction. Because in our course, we will deal with maybe n by n matrix. Did you see n by n matrix last semester? N by n. Prove for all n. Okay, so you need to prove for using induction. And true for all n. Statement that true for all n, you need to use induction. All n in a Z, I mean. You cannot induct on real number, okay? You get what I mean? Induction is only work for integer or natural. Okay. Finally, after proof, we will have some times we will introduce notation or make a remark. Okay, and then sometimes I will make a sign. Okay, after theorem or definitions. Okay, to point out important stuff. Okay, any question to this structure here? So you need to remember every time you need to go through this list. Okay, so maybe sometimes I skip. Okay, I carelessly skip. I don't tell you the motivation or question or observation. You can ask me. Okay, you just ask me. Okay, so this should become your mindset. Okay, so meaning, why I do this? Okay, then I do this. How to do this? Okay, so why I do this? Okay, how to do this? Okay, and then we'll see how to use it. Okay, yeah, something like that. Okay, so in each level, if you are not sure, then you just ask. Okay, is that okay? So we'll try to adopt this line of flow for every new theory discussed. Does that make sense? Any question? No? Okay, let's see how we adopt this method to work. So let's start the real business here. So the first topic we have is a group and subgroup. Okay, let's see why are we interested in these group and subgroup. So one motivation I can give is the symmetry of a triangle. Okay. Let's see what the symmetry of a triangle is. So we'll call this set of symmetry, we call it D3. Okay. When I talk about triangle here, right? So what I really mean is the equilateral triangle. Okay, you have the same side. So you have the same side all the way. All right, so what can you do to this triangle? Okay, to keep this triangle the same, what operation you can try to do? Can you imagine? Rotation, okay? So how many degree you can rotate? How many degree you rotate so that this come back as the same triangle? Okay, so I haven't defined what the symmetry is, right? Okay, you should ask me what the symmetry is. So symmetry of a triangle means you fix your triangle, okay, but doesn't fix every point. Okay, so you apply the symmetry, you get back the same triangle. That's all. Okay. Yeah. So you can do rotation. How many degrees rotation you can do? 120. 120. 120. What is 2 pi over 3 is what? Yes, 120. Okay, so let me write. So if you do 120 rotation, wait, how to write degree? Okay, 120 rotation, then you will get back the same triangle. Okay, what else can you do? Anything else you can do? So let me write something. Let me label this vertex. Okay. So if you do 120 change turn, what do you get? What do you get? You get the same triangle, but the vertex change, right? Okay. So the vertex change to what? 3, 1, 2. Can everyone see this? Okay. So I am doing 120 clockwise around there. Where's my origin? Where's my turning point? Is the middle of this. Okay. So this is where I take the fixed point is. Okay. So this is the point I do rotation clockwise. Okay. What else can you do? What else can you do? Sorry? 360. Sure, you can do 360, but it's just 220 doing it 3 times. Okay, so you can get from this 120 operation here. Anything else you can do? Yeah, flip. Okay, so what do you mean by flip? Refraction along where? Vertical line. Okay, so you want to perpendicular bisect it. Is it? So you need to perpendicular bisect this. Okay, and then you do a reflection. Okay, so you can do a reflection. So if you do this reflection, what do you have? So let me this one reflection. So when you do reflection, what do you have? Your vertex become 1, 3, and 2. Okay. And then it can be shown that actually these two operations generate all the symmetry for the symmetry of triangle. Okay. So for example, instead of perpendicularly dissect from 1, can we perpendicularly dissect from 3? Can we do this? Can we do this and do a reflection? Yes. Okay. So what's the triangle we will get here? And let's do a rotation like this. So what's the triangle we'll get? We'll get 2, 1, 3 instead. Okay? But just now I claimed what? I claimed that using this two operation here, we can generate any symmetry of this triangle. Meaning, if I do enough of these, I can get this operation here. Can everyone understand the statement? Hello? Can everyone understand the statement here? Can see that this symmetry is not coming from these two operations directly, right? So meaning that if you rotate, flip, and rotate and flip, somehow a finite times you'll get the new symmetry here. Okay? Can you understand the statement? Maybe you don't know how to do. Do you understand the statement yet? Understand? Okay. So now I want to give you 5 minutes. Okay. Talk to your friends. Okay, beside you. Okay. Introduce yourself, and then you discuss how to get this new operation reflection along this line number 3 from these two operations, all operation. Okay. Rotation. Let me write down. So you have two operations here. And so one is, let's call this line X. So one is a reflection along X. Okay. The other one is rotation 2 pi over 3 clockwise. Okay. So I give you 5 minutes and see if you can do with enough 2 steps here to get the new symmetry. Yeah, I give you 5 minutes. Discuss with your friend. Yeah. Yeah, you can make noise now. Please make noise. Okay. Is it hello? Is it understandable? So try and write reflection along Y using these two operations here. Two things you only can do: rotate 120 clockwise or reflect and x-axis. Write down, try and write down how to verify, check your vertexes. Yeah, Yep. Okay. Okay. So yeah, sure. So I'm a little bit sloppy in introducing the word symmetry here. Okay. So to be precise, maybe I want isometry. So let me write the definition here. Okay, so for the purpose of this example here, motivation here, this is not general. So for the purpose of this demo, a symmetry triangle is an operation or if you want linear transformation that fixes the triangle. Okay, so it's an operation, it's a function, it's a linear transformation. Okay. So previously I told you you can do reflection, you can do rotation. Okay, but now I rotate along a different line. Okay, so this is different from these two operation, right? How to differentiate it? Because I got a different label of the triangle. Correct or not? Do I have 2, 1, 3 before? No, right? I have 3, 1, 2 or 1, 3, 2. Okay, so how to obtain this new operation? Okay, anyone have any idea? Anyone got it? Or anyone try something? Means you? What have you tried? Okay, it's equivalent, that's fine. What did you do? Sure. Okay. You mean something like this? Yes. BSC, I mean, let me try. So 1, 3, and then BSC, yeah. Different type of symmetry. Okay, wait. So I just want an answer that which reflection you use, which rotation you use, which order you use to get the new symmetry. That's all I want. You get what I mean? I want you to tell me which operation you use to build this new symmetry here. I already tell you you can definitely get it, but you need to tell me how to get it. Does it make sense? Mm-hmm. So every time you rotate, okay, so you rotate once, you get 3, 2, 1, right? You rotate the other times, you get 2, 3, 1. Okay. Okay, so 3 times. Yeah. Yeah. Yeah, okay, let me, okay, good. So wait, so you do one rotation, okay, let me denote rotation like this. Okay, let me use some notation here. So this is rotation, so this is reflection, okay? So if I do one rotation, we will get 3, 1, 2. Okay, then what else you want to get? Rotate again. Okay, let's rotate another time. And then you will get, what do you get? 2, 3, 1. That right? And then you mean do reflection on 2, 3, 1. Is it? Okay, I mean, just focus on getting one star first, right? Just focus on getting one star. Okay, I want to get 213, like in your language. I want to get 213. How do I get 213 here? You do the reflection on 312. So actually, you don't need to go this far, is it? 312, right? Yeah, so you start with 1, 2, 3 triangle, okay, and then you do a rotation. Okay, so you get 312. Correct? Okay, so how to reach 213 in your language? You reflect 231. Okay, so you do reflection on 231. So let us draw again. Let's draw again. 231. Okay, and then you do reflection, right? On the X line. You cannot use this because I want this new operation coming from 2 or operation here. You cannot use this operation now, right? Okay, what you can only do is you rotate to 120 and you reflect along this X line here. Okay, this is the only 2 things you can do. Huh? Okay, you want to try again or? Okay, you try again. So let's scrap this first. Any other answer or not? Reflect first. Okay, sure. Let's reflect first. So if we do reflection, what do we get? 132, good. Okay, so if we do reflection, we get 132. And then rotate. How to rotate? Okay, rotate by 2/3 pi. Y direction. Okay, good. So which is what? Which is 2, 1, 3. Okay, good. Yeah. Okay. Yeah, this is one way to get it. Okay. Does it make sense? Make sense? Okay. All right. So, yeah. So you see, so these words are so long. Okay, I use symbol to represent it. Similarly, I can use alphabet to represent it. So maybe we can call reflection as X, and we can call rotation as R. Okay, and then X satisfies some relation. Okay, if you do X twice, you get back to identity. Okay, you get back to identity, right? If you split twice, you get back to identity. How about rotation? You do twice, 3 times, and then you get back to identity. So this side is what we call a relation. And then this side is what we call a generator. Okay. So we just only need to start with X and R. Okay. Okay, so this is a big picture here. So let's go into new real business. So let's introduce definition. Okay. So definition, first definition I want to give is a set. Okay. So first we must have something to play with. Okay, these are the things we call set. So a set X is a collection of elements. Okay. So a set S is a collection of elements. So notation. Okay. So we will write A contained in X. Okay. If A is an element of X. And or we could write X contains A. Okay. If X contains A. So these two means the same things, but the attitude is different. Okay. Just the attitude is different. One contains in the other contains something. Okay, they are the same, but attitude is different. So, like last time I mentioned to you, the math symbol represent a English sentence. Yeah, so although they have the same result, but the English sentence is different. Make sense? Yeah. Last time I stressed in your project. Okay, so for example, what kind of set we are interested in? Okay, so first of all, we have the natural number. Okay, so these are collection of 1, 2, 3, 4, 5, 6, and so on. Okay. 2, we have integer. Okay, we have integer. So integer contain the negative integer, non-positive, and positive integer. So I think I might want to include 0 in my natural number. Okay, although some argue that 0 is not natural. Yeah. Sorry? Yes, in this course, yes. Yeah. 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 In this course, we include 0 in the natural number. Okay. For easy purpose. Like. Okay. 3. What can you do? You can do integer modulo n. Yeah, you can do integer modulo n. So what are these elements here? What are the elements inside integer modulo n? Is it a number? Not quite. Okay. So you need to adopt a definition that integer modulo n is a set of equivalent classes. Okay, it is a set of equivalent classes. Do you remember what the equivalent classes is? What are equivalents in, for example, let me put another example. Z, let me think. Z, Z3. How about Z3? Okay, Z3 has 3 elements here, right? Okay. So what are these 0, 1, 2 represent? These are set of integer that are modulo n equivalents. Okay, for example, in 0 bar, you have -6, -3, 0, 3, 6, and so on. Okay. So these equivalence classes are a set. Okay. Are sets. Okay. How about 1? What is in the equivalent classes of 1? -7, -4, -1, 0, 1, and then you can keep going. Okay. So you can see that actually this equivalent class are infinite. They are infinite. Does it make sense? Should I recall modulo n or not? Does everyone get it? Because we will be using it. Yeah. Question. -5 is in the equivalent set. minus 5, minus 2, and then 1, and then 4, 7. No, we can try. Okay. So you mean minus 5, is it? So minus 5 is equivalent to what mod 3? It's equivalent to minus 2 mod 3, right? Okay. So what is minus 2 mod 3? 1 mod 3. Okay, so it's a 1 mod 3. Okay, so minus 5 should be in there. So should minus 7 in here or not? Okay, so let's compute. Okay, let's verify what is minus 7. Okay, minus 7 is equivalent to minus 4 mod 3 is equivalent to minus 1 mod 3 is equivalent to 2. Okay, good. So this is not in here. So let's brush it out. Yes. How about minus 4? Okay, so how about I use another method? Okay, minus 4 is what? Minus 4 is the thing that add to 4, you get 0. Okay, in mod 3. So let's compute quicker. So minus 4 is equal to 1 mod 3. Wait, let me see. 2 mod 3 because 4 plus 2 is equals to 0 mod 3. Okay. Okay. So this guy is not in here as well. Okay, but these guys are actually in the equivalent class of 2. So move it down. What else is in here? And minus 1 is 2, so minus 1 is also not in here. Okay, but instead, minus 2 is in the equivalent class of 1. Okay. Yeah, 0 cannot exist, yeah. Because 0 is already in the 0 equivalent class. Okay, yeah, okay. So, what I want to say is this integer modulo n is a set of set. Okay, they are set of set. That's why we put a bar here. Okay, we put a bar here because these are just representative. Okay, they are just representative. Equivalently, I can put minus 3 as my representative as well. Okay, or I can put minus 2 as my representative for the equivalent class of 1. Okay, I can change the representative. Okay. Why is it well defined? Because they are all modulo the same number mod n. Okay. Make sense? Okay. Okay, good. Okay, next next very important example from your calculus. We have real numbers. Okay, real numbers have natural numbers, integers, rational numbers, and irrational numbers. Okay, all of them. Okay. So these are the rational number, real numbers. Number 5. A very important example from your linear algebra, again, is the n by n matrices. Okay, n by n matrices. So these are all the example we want to study. Okay, so n by n matrices. Okay. So why abstract algebra is general? Because you can see it everywhere. Okay, calculus until algebra. Okay. Yeah. Similarly, if you want to do something more fancier, you can do continuous function. Again, the set of continuous function. Let's denote it as C0, function from R to R. Okay, continuous function. Okay, you should recall from last semester. And I think for Junsen, we'll see it soon. Okay. And then finally, we have these just now the toy example, the triangle symmetry. The triangle symmetry. D3. Okay, so what do we have in D3? We have the reflection. Okay, we have the rotation. Okay, we also can do nothing. Okay, let's call E the identity. In this course, we will put E as our identity. Okay, you will see in some book they put 1. Okay, so in our course we use E. And then you can compose them like what we do just now. Okay, do R first and then do X. So how we see composition here is the right one is the function that we do first, and then we do the left one. Okay, this is how we read it. Okay. All right. So these set. Okay. So one very important, maybe trivial but very important, is there's exactly one set with no element. You know what that set is? The empty set. Okay, good. So, but I want you to appreciate this statement here. Why important is this statement? What does this statement give you? Exactly one. Okay. In mathematics, we say this is a uniqueness and existence. Okay. Whenever we talk about these mathematical statement, we care about uniqueness and existence. Okay. Does this exist or not? Does there a set with no elements or not? Okay. Does my definition of set allow these things to happen or not? Okay. So we care about uniqueness and existence. Okay. Sometimes we will write in a mathematical notation as there exists an exclamation mark. Okay. There exists and then the only one exclamation mark. Okay. Very happy, only one only. Exclamation mark. So do we allow this to happen? What's the definition of a set? Can anyone recall now? Yeah, a collection of elements. Okay, it's a collection of elements. Oh, by the way, in my class, right, you don't need to do copy down my notes because I will post out after the lecture. I will post out a blackboard notes and then lecture notes later. Okay, I'll refine it and then I post it up. So the set doesn't say whether it's empty or not. Okay, so we can consider empty set. Okay, empty collection. We can consider empty collection. Okay, so it exists. Okay, unless I say non-empty collection, then it must be something inside. Okay, but there's no adjective here. Okay, so we are allowed with an empty collection. Okay, so let me put down the proof. So existent, we can have an empty collection of set. Okay, we can have an empty collection. I'm sorry, what am I doing? An empty collection of elements. Okay. Yeah. Okay. So be careful. Be careful when I write something or when I say something. Because sometimes when I think, right, it's not what I wrote or what I said. So you should ask me again. Okay. Because there's always 嘴瓢 as a 嘴瓢. So yeah, you should ask me. Okay. When I wrote something, you think there's some problem, you should ask me. Okay, existence. We can have an empty collection of elements. Okay, how to prove uniqueness? Uniqueness, there's one technique. Okay, there's one technique, one general technique to prove uniqueness. So what is unique? What is unique? Only one. How to tell people there's only one? Yeah. So you take two things that have the same properties and then show that they must be the same. Then this is how you tell people there's only one. Okay. If you don't believe, take the other one. See it is the same or not. Okay. So mathematically, how should we write this? Suppose, okay, suppose there are two sets with no elements. Okay, suppose there are two sets with no elements. So let's give them a name. Let's call it A and B. Suppose two sets have no element. We need to show that A is equals to B. Okay, we need to show that. We want to show A equals to B. So what is equal means here? Discrete math. You have two sets and then you want to set equal. Okay, this is the result. What's the definition? If they're equal, definitely they have the same size. Same element. Okay, same element. Still remember the definition of what you need to show. Yes, subset. Okay, A is in B and B is in A. Okay, you need to show these two statements here. Okay, let's do one of them. Okay, let's show A in B. Suppose X is in A. Okay, but there's nothing in X. Right? But there's nothing in X. Okay, so there's nothing in X. We want to show that X in B. Okay? Or in other words, or equivalently, what do we want to show? For every X in A, X in A implies X in B. Okay, so this is what we want to show. Okay, very well. Okay, but there's nothing in A. P is always false. False implies everything. Remember? Does everyone remember? Remember the truth table here? Yeah, so you should recall your discrete math. So let's recall. What's the truth table for P implies Q? So it's very crucial what you learn in the maths, discrete math. So we have true, 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 false, false, true, and false, false. So true, 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 false, 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 true, true, false, false, true. So you can see that if P is false, no matter what is Q, P implies Q is always true. Okay. So this means the statement we want to prove is always true. Okay. Does it make sense or not? Make sense? If doesn't make sense to you, you should shout out now. Okay. Otherwise, you will suffer for 15 weeks. Okay. Okay. So I'll go on. So since X is not in A, we have A, A is a subset of B is always true. Okay. Or sometimes we will say that it is vacuously true. Yeah, there's nothing there vacuously true. Okay. Vacuously true. Okay. Does it make sense? Then similarly, the other direction is the same. B is a subset of A. B also have no elements. So you can use the same method to prove. Okay. By the same argument, by similar argument, we get B is a subset of A. Why? Because B is also has no elements. Okay. Okay. Does it make sense? Yeah. Yeah. Question.
What about the existence? Only about one sentence.
Yeah. For this case. Yes. Sometimes it's hard. Sometimes, yeah. So this exister is kind of a big problem actually, especially in analysis. Okay, some statement is easy to get uniqueness. You can see that but you don't know whether it exists or not. This argument should work. Okay, so typically uniqueness is easier to prove than existence. Okay? Existence, you need to find one. Yeah. Uniqueness, you just use some trick like this. Is that uniqueness? No, that doesn't imply each other. Some things can be unique, but it doesn't exist. Something can exist, but it is not unique. I mean, this is the usual case. Exists, but not unique. Yeah, right? Like there exists a boy. Is Ying the same as Kimpo? No, right? Correct? This is the usual case. Yeah. So we are very happy if it is exactly one. There's only one we need to take care of. Unique but not existent. Need to argue why I am unique still. Unique but doesn't exist.
Yeah. I'm confused on this.
Yeah, confused on this. Oh, so what's unique? Does anyone have any idea? Unique but doesn't exist. Huh? String. Is it unique? How is it unique? Unique but doesn't exist. Yeah, let me think. Okay, I can't come out with one example. Maybe next time. Okay, send for next time. I'll tell you. There must be one, but I can't think of one interesting one now. Eh? Unicorn? Okay, yeah, unicorn works. Mermaid also works. Huh? There's so many mermaids. Okay. Unicorn is unique, is it? Okay. There are many. So what's the thing that doesn't exist?
Maybe the god or something.
That one is very controversial. That one is very controversial. Okay.
Snow White.
Snow White. Okay, Snow White. Yeah. I think Snow White is just one, right? If two
Yeah,
Snow White,
Snow
then
White.
yeah. Okay, yeah, sure. Okay, yeah. So there must be something unique but doesn't exist because it already exists in a mathematics segment. There's something like that. Okay. So it's very natural one. Okay, max is very natural. So we collect all these property here and we call this set as a empty set. Okay, I want to warn you, this empty set is very important in future. It's as important as 0 in the number. Okay, this is an equivalent 0 in the set theory. Okay, this is as important as 0. So how do we denote empty set? A circle and a slash. Nothing in there. Okay, so take a look on this statement here. The empty set is a set with no elements denoted by this phi. I already said the empty set, but I said the empty set is a set. Does this well define or not? I said it's a set, right? Just a set. Just a set of no elements. Is this well defined? Is there another empty set or not? No. Why? Why is there no other empty set? Right? Yeah, just by the statement we proved just now. Okay, well defined by the proposition proven above. Okay, so this is how we read mathematics statement. Okay, so this is well defined. This definition is well defined by previous proposition. Of course, I can replace this with a the because by the proposition just now we already know that there's only one. Right? The set with no the set, but I can put as well. Okay, so I'm teaching you how to read these mathematical statements and how to verify them. Okay? Okay? Yeah. Okay, good. So now we have a set. So what do we want to do with a set? You have a Lego. What can you do? So many pieces. What can you play with Lego? Do you just throw the Lego like some of the kids? How to play Lego? You? Wait, never play Lego before, is it? You know what the Lego is? 乐高，乐高，乐高，没有玩过。怎么玩？ How to play? 用手玩。That's why I ask you. Do you throw it? Just throw. Just throw. Hey, some kids really just throw the Lego, you know. Yeah. So
eat the Lego.
Yeah, I eat the Lego even. So how to play Lego? You build it. Okay, you compose it. Okay, you put them together to form another Lego or building. Okay, so with a set, what can you do? You can say whether I can compose two elements in the set or not. Okay, this is what we call a law of composition. And this is very crucial in our definition of group. So there's law of composition, we call LOC. On a set, X is a function of two variables. Okay, so a law of composition is a function of two variables from the product group of X cross X to X. Okay, you go back to the same set. Okay, so if you compose two elements in the set, you get another element in the set. Okay, make sense? So let me write it, everything out. So this is the product set of the product set. Okay. Sometimes we call it a binary operations. Sometimes we call it a binary operation. Why is it binary? Because we take in two input. Okay? We compose two elements and then get back another element. And then we will write the set with its composition. So we will write the set X with its law of composition as S, comma, star. Okay. So we have a set X. Okay, we have a composition function. Okay, law of composition tells you how to compose two things. Okay, so another definition we want to make before we jump into example is a law of composition is associative if it satisfies A star bracket B star C equals to A star B star C. Okay. So why associative is interesting? You know why? Binary operation only tells you how to combine two elements. How about you want to combine three elements? What do you do? What can you do? If you want to combine three elements, what can you do? You can either combine the first two or you can combine the last two first. Right, okay? So associativity tells you that doesn't matter which one you choose to do first. Okay, they are the same. And that's why this is important, associativity. Okay. Either you want to compose the first two first or you want to compose the last two first, is the same result. Okay, so this is very important here. And then the next one is the commutativity. Okay, it is commutative if A star B is equal to B star A. Okay, okay, so you can commute. Okay. A and B commute. All right. So you can see here, what I want you to see here is when you look at this definition, right? there's something you want to take note here. So the first definition here is a noun. Okay. 是名词. Okay, it's a noun. The second and third is an adjective. Okay, it's a 形容词. Okay, adjective. So adjective need to work on a noun. Okay, when you say it is commutative, then you need to tell people what is commutative. Okay, the law of composition is commutative. Okay, so adjective have to come with a noun. Okay. Yeah. So you say what is beautiful? Maybe that girl is beautiful, or that object is beautiful. So you cannot just say, it is beautiful. Very beautiful. What is beautiful? I don't know what you are talking about. Okay, so something is beautiful. So adjective has to work for a noun. Okay. Okay. The OA want to see whether you got leave early or not. Okay. Okay, let's do some example and then we will finish today. So law of composition. Just now we have a natural number. Okay. So what we can do on natural number? We can addition. Okay, we can add them. We can also multiply them. Okay. So we can add them. We can multiply them. Okay. Similarly for integer, we can add them. We can multiply them. Okay. And then what else? For the integer modulo n, we also can add them, and we also can multiply them. What else we have just now? Let me see. So real number. Okay, real number is the same. We can add them. Okay, we can multiply them. What else? Matrices. What can we do with matrices? We can add matrices. We can also matrix multiplication. Okay, this is not the usual multiplication, it's the matrix multiplication, right? The row times column, row times column, row times column. Okay. What else? Our function, is it? Continuous function. Okay, continuous function. What can we do with continuous function? Can we compose or not? How to compose continuous function? Just function composition, F composed with G. Okay, this is the function composition. Okay, function composition. Okay, and then the symmetry stuff, maybe we just get rid of it. Okay, so out of these, are these operations associative or not? Okay, does it satisfy this equation here? 1 plus 2 plus 3 equals to 1 plus 2 first and then plus 3. Okay, so these are built into our operation actually. But for matrix, you need to check. Okay, but this is one of the theorem you establish inside your algebra. But I'm not sure you prove it or not. If not, maybe we prove it in this assignment. Okay. Okay. So yeah. Okay, associative. And then function composition is also associative. How about commutative? Okay. How about commutative? Which are these are not commutative? Matrix multiplication is not commutative, right? AB is generally not equal to BA. Then matrix AB is not generally equal to BA. You can easily come up with examples. Okay, but for numbers, real numbers, they are commutative. Okay, function composition is also not commutative. Okay, this is also not commutative. Okay. Okay. Right. Any question before we take a break? Yeah, finish. Finish for the day. Any question? No? Okay. So because this is the first class, so I will go slower. Usually I go slower in first class, then later we will speed up a bit. Okay. Yeah. Sorry? LOC. Okay. LOC need to be a function of two variables from S cross S to X. It's a function. So how to be a well-defined function? You cannot have one thing that's sent to two different things. That means if you compose two elements, you cannot be another type. Yeah, it just need to be a function. Okay. Just tell me if I give you two elements, how to get another element. Okay? Yeah. That's all. All right. So we'll see you on Wednesday.